Hello and welcome to this math tutorial. Which is greater, 2000 raised to the power of 3000? Is it greater than 3000 raised to the power of 2000? Or will it be 3000 raised to the power of 2000 that will be greater than 2000 raised to the power of 3000? Now, the only way to find out is when we apply the formula for calculating the number of digits in a number. Okay, so if you want to calculate the number of digits in a number, okay, let me explain that, and then once I derive the formula, then we can use it to find out which one of these two is greater. Okay, all right. So let's say we have, let me choose a letter x. X represents a number with n digits. Okay, that is, n represents number of digits. N represents number of digits. Now, then I'm going to set my range. Okay, the range that represents, just like an inequality, okay, which represents the range of number with n digits. And that will be when we have 10 to the power of n minus 1, okay, less than or equals to x, less than 10 to the power of n. Then I'll take logarithm to base 10 of both sides. All right, so taking logarithms to base 10 of both sides. Okay, taking logarithm to base 10. In this case, we're going to have logarithm to base 10 of 10 raised to the power of n minus 1 less than or equals to logarithm to base 10, okay, of x less than logarithm to base 10 of 10 raised to the power of n. Now, we can then transform this into what we call linear range. So for linear range, this will reduce to n minus 1 less than or equals to logarithm to base 10 of x, okay, less than n. Okay, then I can add 1, okay, to both sides. So in this case, this will reduce to n less than or equals to logarithm to base 10 of x plus 1 less than n plus 1. So the formula for calculating the number of digits in a number is n equals to logarithm to base 10 of x plus 1. So this formula, we're going to use this formula, to verify, to find out which one out of these two numbers is greater. Okay, so now let's start. So what I'll do first is I'm going to represent each number with a letter. So let P equals to 2000 raised to the power of 3000 and Q equals to 3000 raised to the power of 2000. Okay, and then we can now apply the formula, applying the formula n, which is a number of digits in number x. So in this case, number p, that will be equals to, so in the case of p, that will be equals to logarithm to base 10 of p, okay, plus 1. So I'm going to substitute this for p. So we have n subscript p equals to logarithm to base 10 of 2000 raised to the power of 3000, then plus 1. Okay, so let me bracket this. So this will be plus 1. Now in this case, this will be logarithm. Now n subscript p will be equals to 3000 multiplied by logarithm to base 10 of 2000. Okay, 2000 then plus 1, because I just apply the property, the logarithm of nth power of p, okay, to base 10, okay, will be equals to the product of n log p to base 10. So, which is one of the properties of logarithm. So in this case, this now becomes 3000 open square bracket. This will be logarithm to base 10 of 2 plus logarithm to base 10 of 1000, then plus 1. Okay, so in this case, we're going to have the number of digits to be equals to 3000 multiplied by square bracket log into base 10 of 2. That will be 0.30301. Okay, why this will be log into base 10 of 10 raised to the power of 3 plus 1. So that the number of digits will now be 3000, okay, multiplied by 0.301 plus 3 log 10 to base 10, which will be 1. Okay, I just apply this property. So this becomes 3000, okay, multiplied by 0.301, then plus 3. Okay, plus 3. That's in this case. Then plus 1. Multiplying this is 3000 times 0.30301. Okay, that will be 903. Of course, that will be 903. So that will be 903. Why this would be 9000, then plus 1. So this would be 9000 plus 903. That will be, everything will be 9904. So this is the number of digits in 2000 raised to the power of 3000. All right. So then also so like I said, the number of digits, okay, in this will be 9904. So let me box this. All right. So for the other one, we have Q. We have Q, which is equals to 3000 raised to the 2000. And we know that the number of digits will be logged into base 10 of Q, okay, plus 1. So we have number of digits will be equals to logged into base 10 of 3000 raised to the 2000, then plus 1. So then this becomes 2000 multiplied by logged into base 10 of 3000, then plus 1. So that this will be equals to 2000 open square bracket. This is logged into base 10 of 3 plus logged into base 10 of 1000, then plus 1. Okay, so that this will be 2000. Then we have this to be logged into base 10 of 3. That will be 0.4771. Okay, then plus, this is 3, then plus 1. Now multiplying this, okay, if we multiply 477 divided by 1000 by 2000, I want to neglect this. So this will be 2. So multiplying 2 by 477, that is that will be 954. So this is going to be 954. Okay, 954 plus, this is going to be 6000, then plus 1. All right. So now if we add this will be 955, then plus 6000. So this is going to be 6955, which is the number of digits in 3000 raised to the power of 2000. Now let's compare. Now from here, we know that for NP, okay, NP is 9904. And when we look at NQ, NQ is 6955. So we can see that NP is greater than NQ. So therefore, 2000 raised to the power of 3000, okay, is greater than 3000 raised to the power of 2000. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.